Computer graphics are graphics created using computers and the representation of image data by a computer, specifically with help from specialized graphic hardware and software. The interaction and understanding of computers and interpretation of data has been made easier because of computer graphics. Computer graphic development has had a significant impact on many types of media and have revolutionized animation, movies and the video game industry. Overview: the term computer graphics has been used in a broad sense to describe almost everything on computers that is not text or sound. Typically, the term computer graphics refers to several different things: the representation and manipulation of image data by a computer, the various technologies used to create and manipulate images, the subfield of computer science which studies methods for digitally synthesizing and manipulating visual content. See Study of computer graphics. Computer graphics is widespread today. Computer imagery is found on television, in newspapers, for example in weather reports, or for example in all kinds of medical investigation and surgical procedures. A well-constructed graph can present complex statistics in a form that is easier to understand and interpret. In the media, such graphs are used to illustrate papers, reports, thesis, and other presentation material. Many powerful tools have been developed to visualize data. Computer-generated imagery can be categorized into several different types: two-dimensional, three-dimensional, and animated graphics. As technology has improved, 3D computer graphics have become more common, but 2D computer graphics are still widely used. Computer graphics has emerged as a subfield of computer science which studies methods for digitally synthesizing and manipulating visual content. Over the past decade, other specialized fields have been developed like information visualization, and scientific visualization more concerned with the visualization of three-dimensional phenomena, where the emphasis is on realistic renderings of volumes, surfaces, illumination sources, and so forth, perhaps with a dynamic component. History. The precursor sciences to the development of modern computer graphics were the advances in electrical engineering, electronics, and television that took place during the first half of the 20th century. Screens could display art since the Lumiere brothers' use of mattes to create special effects for the earliest films dating from 1895, but such displays were limited and not interactive. The oscilloscope, the complex avionics control panel, and the naval control panels of the World War II period would prove to be the more direct precursors of the field, as they provided the first two-dimensional electronic displays that responded to user input. Early projects like the Whirlwind and Sage projects introduced the CRT as a viable display and interaction interface and introduced the light pen as an input device. A programmer for the Whirlwind Sage system performed a personal experiment in 1954 in which a small program he wrote captured the movement of his finger and displayed its vector on a display scope. The same individual, Douglas T. Ross, working at MIT on transforming mathematical statements into computer-generated machine tool vectors in 1959, took the opportunity to create a display scope image of a Disney cartoon character. One of the first interactive video games to feature recognizable, interactive graphics was created for an oscilloscope by William Higginbotham to entertain visitors in 1958 at Brookhaven National Laboratory and simulated a tennis match. The phrase OE computer graphics Euro itself was coined in 1960 by William Fetter, a graphic designer for Boeing. The field of computer graphics developed with the emergence of computer graphics hardware. Initial developments, further advances in computing led to greater advancements in interactive computer graphics. In 1959, the TX2 computer was developed at MIT's Lincoln Laboratory. The TX2 integrated a number of new man-machine interfaces. A light pen could be used to draw sketches on the computer using Ivan Sutherland's revolutionary Sketchpad software. Using a light pen, Sketchpad allowed one to draw simple shapes on the computer screen, save them and even recall them later. The light pen itself had a small photoelectric cell in its tip. This cell emitted an electronic pulse whenever it was placed in front of a computer screen and the screen's electron gun fired directly at it. By simply timing the electronic pulse with the current location of the electron gun, it was easy to pinpoint exactly where the pen was on the screen at any given moment. Once that was determined, the computer could then draw a cursor at that location. Sutherland seemed to find the perfect solution for many of the graphics problems he faced. Even today, many standards of computer graphics interfaces got their start with this early Sketchpad program. One example of this is in drawing constraints. If one wants to draw a square, for example, they do not have to worry about drawing 4 lines perfectly to form the edges of a box. One can simply specify that they want to draw a box, and then specify the location and size of the box. The software will then construct a perfect box, with the right dimensions and at the right location. Another example is that Sutherland's software modeled objects, not just a picture of objects. In other words, with a model of a car, one could change the size of the tires without affecting the rest of the car. It could stretch the body of the car without deforming the tires. Further 1961 developments. Also in 1961, another student at MIT, Steve Russell, created the first video game, Space War. Written for the DEC-PDP-1, Space War was an instant success and copies started flowing to other PDP-1 owners, and eventually even DEC got a copy. The engineers at DEC used it as a diagnostic program on every new PDP-1 before shipping it. The sales force picked up on this quickly enough, and when installing new units, would run the world's first video game for their new customers. E. E. Zajac, a scientist at Bell Telephone Laboratory, created a film called Simulation of a Two-Gyrogravity Attitude Control System in 1963. In this computer-generated film, Zajac showed how the attitude of a satellite could be altered as it orbits the Earth. He created the animation on an IBM 7090 mainframe computer. Also at BTL, Ken Knowlton, Frank Sinden and Michael Knowles started working in the computer graphics field. Sinden created a film called Force, Mass and Motion, illustrating Newton's laws of motion in operation. Around the same time, other scientists were creating computer graphics to illustrate their research. At Lawrence Radiation Laboratory, Nelson Max created the films, Flow of a Viscous Fluid, and Propagation of Shock Waves in a Solid Form. Boeing Aircraft created a film called Vibration of an Aircraft. It was not long before major corporations started taking an interest in computer graphics. TRW, Lockheed Georgia, General Electric and Sperry Rand are among the many companies that were getting started in computer graphics by the mid-1960s. IBM was quick to respond to this interest by releasing the IBM 2250 graphics terminal, the first commercially available graphics computer. Ralph Baer, a supervising engineer at Sanders Associates, came up with a home video game in 1966 that was later licensed to Magnavox and called The Odyssey. While very simplistic, and requiring fairly inexpensive electronic parts, it allowed the player to move points of light around on a screen. It was the first consumer computer graphics product. David C. Evans was Director of Engineering at Bendix Corporation's computer division from 1953 to 1962, after which he worked for the next 5 years as a visiting professor at Berkeley. There he continued his interest in computers and how they interfaced with people. In 1966, the University of Utah recruited Evans to form a computer science program, and computer graphics quickly became his primary interest. This new department would become the world's primary research center for computer graphics. Also in 1966, Sutherland at MIT invented the first computer-controlled head-mounted display. Called the Sword of Damocles because of the hardware required for support, it displayed 2 separate WIRI frame images, one for each eye. This allowed the viewer to see the computer scene in stereoscopic 3D. After receiving his Ph.D. from MIT, Sutherland became Director of Information Processing at ARPA, and later became a professor at Harvard. In 1967, Sutherland was recruited by Evans to join the computer science program at the University of Utah. There he perfected his HMD. 20 years later, NASA would rediscover his techniques in their virtual reality research. At Utah, Sutherland and Evans were highly sought-after consultants by large companies, but they were frustrated at the lack of graphics hardware available at the time, so they started formulating a plan to start their own company. In 1969, the ACM initiated a special interest group in graphics which organizes conferences, graphics standards, and publications within the field of computer graphics. In 1973, the first annual SIGGRAPH conference was held, which has become one of the focuses of the organization. SIGGRAPH has grown in size and importance as the field of computer graphics has expanded over time. 1970s, many of the most important early breakthroughs in computer graphics research occurred at the University of Utah in the 1970s. A student by the name of Edwin Catmull started at the University of Utah in 1970 and signed up for Sutherland's computer graphics class. Catmull had just come from the Boeing Company and had been working on his degree in physics. Growing up on Disney, Catmull loved animation yet quickly discovered that he did not have the talent for drawing. Now Catmull saw computers as the natural progression of animation and they wanted to be part of the revolution. The first animation that Catmull saw was his own. He created an animation of his hand opening and closing. It became one of his goals to produce a feature-length motion picture using computer graphics. In the same class, Fred Park created an animation of his wife's face. Because of Evans and Sutherland's presence, UU was gaining quite a reputation as the place to be for computer graphics research, so Catmull went there to learn 3D animation. As the UU Computer Graphics Laboratory was attracting people from all over, John Warnock was one of those early pioneers. He would later found Adobe Systems and create a revolution in the publishing world with his PostScript page description language. Tom Stockham led the image processing group at UU, which worked closely with the computer graphics lab. Jim Clark was also there. He would later found Silicon Graphics, Incorporated. The first major advance in 3D computer graphics was created at UU by these early pioneers, the hidden surface algorithm. In order to draw a representation of a 3D object on the screen, the computer must determine which surfaces are behind the object from the viewer's perspective, and thus should be hidden, when the computer creates the image. The 3D Core graphics system was the first graphical standard to be developed. A group of 25 experts of the ACM's Special Interest Group SIGGRAPH developed this conceptual framework. The specifications were published in 1977, and it became a foundation for many future development in the field. 1980s. In the early 1980s, the availability of bit slice and 16-bit microprocessors started to revolutionize high-resolution computer graphics terminals, which now increasingly became intelligent, semi-standalone and standalone workstations. Graphics and application processing were increasingly migrated to the intelligence in the workstation, rather than continuing to rely on central mainframe and mini-computers. Typical of the early move to high-resolution computer graphics intelligent workstations for the computer-aided engineering market were the Orca 1000, 2000 and 3000 workstations, developed by Orcatech of Ottawa, a spin-off from Bell Northern Research, and led by an early workstation pioneer David Pearson, computer scientist. The Orca 3000 was based on Motorola 68000 and AMD bit slice processors and had Unix as its operating system. It was targeted squarely at the sophisticated end of the design engineering sector. Artists and graphic designers began to see the personal computer, particularly the Commodore Amiga and Macintosh, as a serious design tool, one that could save time and draw more accurately than other methods. In the late 1980s, SGI computers were used to create some of the first fully computer-generated short films at Pixar. The Macintosh remains a highly popular tool for computer graphics among graphic design studios and businesses. Modern computers, dating from the 1980s, often use graphical user interfaces to present data and information with symbols, icons and pictures, rather than text. Graphics are one of the 5 key elements of multimedia technology. 1990s. 3D graphics became more popular in the 1990s in gaming, multimedia and animation. At the end of the 80s and beginning of the 90s were created, in France, the very first computer graphics TV series, La Vie des Bâtards by Studio McGuffline, Les Fables Gare copyright Oma copyright Trix J.Y. Graal, Georges Lacroix and Renato and Quex, the first HD TV computer graphics series by Maurice Benioff and Frana Section Washuaiten. In 1995, Toy Story, the first full-length computer-generated animation film, was released in cinemas worldwide. In 1996, Quake, one of the first fully 3D games, was released. Computers adopted common frameworks for graphics processing such as DirectX and OpenGL. Since then, computer graphics have only become more detailed and realistic, due to more powerful graphics hardware and 3D modeling software. 2000s, CGI was adopted en masse for television advertisements in this era, and became familiar to a massive audience. Computer graphics used in films and video games gradually began to be realistic to the point of entering the uncanny valley. Examples include the later Final Fantasy games, and animated films like the Polar Express. 3D rendering capabilities became a standard feature on even inexpensive hardware. Shaders, which had been introduced in the 1980s to perform specialized processing on the GPU, would by the end of the decade become commonplace, speeding up graphics considerably and allowing for greatly improved texture and shading in computer graphics via the widespread adoption of normal mapping, bump mapping, and a variety of other techniques allowing the simulation of a great amount of detail. 2010s, by the early half of the 2010s, CGI is nearly ubiquitous in video, pre-rendered graphics are nearly photorealistic, and even real-time graphics on a suitably high-end system may simulate photorealism to the untrained eye. Shaders are maturing considerably and are now very nearly a necessity for advanced work in the field, providing considerable complexity in manipulating pixels, vertices, and textures on a per-element basis, and countless possible effects. Experiments into the processing power required to provide graphics at ultra-high resolution modes like Ultra HD are beginning, though beyond reach of all but the highest-end hardware. Image types, two-dimensional. 2D computer graphics are the computer-based generation of digital images mostly from models, such as digital image, and by techniques specific to them. 2D computer graphics are mainly used in applications that were originally developed upon traditional printing and drawing technologies such as typography. In those applications, the two-dimensional image is not just a representation of a real-world object, but an independent artifact with added semantic value. Two-dimensional models are therefore preferred, because they give more direct control of the image than 3D computer graphics, whose approach is more akin to photography than to typography. Pixel art, a large form of digital art. Being pixel art is created through the use of raster graphics software, where images are edited on the pixel level. Graphics in most old computer and video games, graphing calculator games, and many mobile phone games are mostly pixel art. Vector graphics. Vector graphics formats are complementary to raster graphics. Raster graphics is the representation of images as an array of pixels and is typically used for the representation of photographic images. Vector graphics consists in encoding information about shapes and colors that comprise the image, which can allow for more flexibility in rendering. There are instances when working with vector tools and formats is best practice, and instances when working with raster tools and formats is best practice. There are times when both formats come together. An understanding of the advantages and limitations of each technology and the relationship between them is most likely to result in efficient and effective use of tools. Three-dimensional, 3D graphics compared to 2D graphics are graphics that use a three-dimensional representation of geometric data. For the purpose of performance, this is stored in the computer. This includes images that may be for later display or for real-time viewing. Despite these differences, 3D computer graphics rely on similar algorithms as 2D computer graphics do in the frame and raster graphics in the final rendered display. In computer graphics software, the distinction between 2D and 3D is occasionally blurred. 2D applications may use 3D techniques to achieve effects such as lighting, and primarily 3D may use 2D rendering techniques. 3D computer graphics are the same as 3D models. The model is contained within the graphical data file, apart from the rendering. However, there are differences that include the 3D model as the representation of any 3D object. until visually displayed a model is not graphic. Due to printing, 3D models are not only confined to virtual space. 3D rendering is how a model can be displayed. Also can be used in non-graphical computer simulations and calculations. Computer animation. Computer animation is the art of creating moving images via the use of computers. It is a subfield of computer graphics and animation. Increasingly it is created by means of 3D computer graphics, though 2D computer graphics are still widely used for stylistic, low bandwidth, and faster real-time rendering needs. Sometimes the target of the animation is the computer itself, but sometimes the target is another medium, such as film. It is also referred to as CGI, especially when used in films. Virtual entities may contain and be controlled by assorted attributes, such as transform values stored in an object's transformation matrix. Animation is the change of an attribute over time. Multiple methods of achieving animation exist. The rudimentary form is based on the creation and editing of keyframes, each storing a value at a given time, per attribute to be animated. The 2D/3D graphics software will change with each keyframe, creating an editable curve of a value mapped over time, in which results in animation. Other methods of animation include procedural and expression-based techniques. The former consolidates related elements of animated entities into sets of attributes, useful for creating particle effects and crowd simulations. The latter allows an evaluated result returned from a user-defined logical expression, coupled with mathematics, to automate animation in a predictable way. To create the illusion of movement, an image is displayed on the computer screen, then quickly replaced by a new image that is similar to the previous image, but shifted slightly. This technique is identical to the illusion of movement in television and motion pictures. Concepts and principles. Images are typically devices such as cameras, mirrors, lenses, telescopes, microscopes, etc. Digital images include both vector images and raster images, but raster images are more commonly used. Pixel. In digital imaging, a pixel is a single point in a raster image. Pixels are placed on a regular two-dimensional grid, and are often represented using dots or squares. Each pixel is a sample of an original image, where more samples typically provide a more accurate representation of the original. The intensity of each pixel is variable. In color systems, each pixel has typically three components such as red, green, and blue. Graphics. Graphics are visual presentations on a surface, such as a computer screen. Examples are photographs, drawing, graphics designs, maps, engineering drawings, or other images. Graphics often combine text and illustration. Graphic design may consist of the deliberate selection, creation, or arrangement of typography alone, as in a brochure, flyer, poster, website, or book without any other element. Clarity or effective communication may be the objective, association with other cultural elements may be sought, or merely, the creation of a distinctive style. Rendering. Rendering is generating a 3D model by means of computer programs. A scene file contains objects in a strictly defined language or data structure. It will contain geometry, viewpoint, texture, lighting, and shading information as a description of the virtual scene. The data contained in the scene file is then passed to a rendering program to be processed and output to a digital image or raster graphics image file. The rendering program is usually built into the computer graphics software, though others are available as plugins or entirely separate programs. The term rendering may be by analogy with an artist's rendering of a scene. Though the technical details of rendering methods vary, the general challenges to overcome in producing a 2D image from a 3D representation stored in a scene file are outlined as the graphics pipeline along a rendering device, such as a GPU. A GPU is a device able to assist the CPU in calculations. If a scene is to look relatively realistic and predictable under virtual lighting, the rendering software should solve the rendering equation. The rendering equation does not account for all lighting phenomena, but is a general lighting model for computer-generated imagery. Rendering is also used to describe the process of calculating effects in a video editing file to produce final video output. 3D projection. 3D projection is a method of mapping three-dimensional points to a two-dimensional plane. As most current methods for displaying graphical data are based on planar two-dimensional media, the use of this type of projection is widespread, especially in computer graphics, engineering and drafting. Ray tracing. Ray tracing is a technique for generating an image by tracing the path of light through pixels in an image plane. The technique is capable of producing a very high degree of photorealism, usually higher than that of typical scanline rendering methods, but at a greater computational cost. Shading. Shading refers to depicting depth in 3D models or illustrations by varying levels of darkness. It is a process used in drawing for depicting levels of darkness on paper by applying media more densely or with a darker shade for darker areas, and less densely or with a lighter shade for lighter areas. There are various techniques of shading including cross-hatching where perpendicular lines of varying closeness are drawn in a grid pattern to shade an area. The closer the lines are together, the darker the area appears. Likewise, the farther apart the lines are, the lighter the area appears. The term has been recently generalized to mean that shaders are applied. Texture mapping. Texture mapping is a method for adding detail, surface texture, or color to a computer-generated graphic or 3D model. Its application to 3D graphics was pioneered by Dr. Edwin Catmull in 1974. A texture map is applied to the surface of a shape, or polygon. This process is akin to applying pattern paper to a plain white box. Multi-texturing is the use of more than one texture at a time on a polygon. Procedural textures and bitmap textures are, generally speaking, common methods of implementing texture definition on 3D models in computer graphics software, while intended placement of textures onto a model's surface often requires a technique known as UV mapping for polygon surfaces, while NURBS surfaces have their own intrinsic parameterization used as texture coordinates. Anti-aliasing, rendering resolution-independent entities for viewing on a raster device such as a liquid crystal display or CRT television inevitably causes aliasing artifacts mostly along geometric edges and the boundaries of texture details. These artifacts are informally called JAGs. Anti-aliasing methods rectify such problems, resulting in imagery more pleasing to the viewer, but can be somewhat computationally expensive. Various anti-aliasing algorithms are able to be employed, then customized for the most efficient rendering performance versus quality of the resultant imagery. A graphics artist should consider this trade-off if anti-aliasing methods are to be used. A pre-anti-aliased bitmap texture being displayed on a screen at a resolution different than the resolution of the texture itself will exhibit aliasing artifacts, while any procedurally defined texture will always show aliasing artifacts as they are resolution independent. Techniques such as MIP mapping and texture filtering help to solve texture-related aliasing problems. Volume rendering. Volume rendering is a technique used to display a 2D projection of a 3D discretely sampled data set. A typical 3D data set is a group of 2D slice images acquired by a CT or MRI scanner. Usually these are acquired in a regular pattern and usually have a regular number of image pixels in a regular pattern. This is an example of a regular volumetric grid, with each volume element, or voxel represented by a single value that is obtained by sampling the immediate area surrounding the voxel. 3D modeling. 3D modeling is the process of developing a mathematical, wireframe representation of any three-dimensional object, called a 3D model, via specialized software. Models may be created automatically or manually. The manual modeling process of preparing geometric data for 3D computer graphics is similar to plastic art such as sculpting. 3D models may be created using multiple approaches: use of NURBS curves to generate accurate and smooth surface patches, polygonal mesh modeling, or polygonal mesh subdivision. A 3D model can be displayed as a two-dimensional image through a process called 3D rendering, used in a computer simulation of physical phenomena, or animated directly for other purposes. The model can also be physically created using 3D printing devices. Pioneers in graphic design. Charles Gshiri. Charles Gshiri is a pioneer in computer animation and digital fine art and created the first computer art in 1964. Gshiri was recognized by Smithsonian as the father of digital art and computer animation, and as a pioneer of computer animation by the Museum of Modern Art and Association for Computing Machinery SIGGRAPH. Donald P. Greenberg. Donald P. Greenberg is a leading innovator in computer graphics. Greenberg has authored hundreds of articles and served as a teacher and mentor to many prominent computer graphic artists, animators, and researchers such as Robert L. Cook, Mark Levoy, Brian A. Barsky, and Wayne Lytle. Many of his former students have won Academy Awards for technical achievements and several have won the SIGGRAPH Achievement Award. Greenberg was the founding director of the NSF Center for Computer Graphics and Scientific Visualization. Aaron Marcus. Aaron Marcus is one of the first graphic designer in the world to work with computer graphics. He has written over 250 articles and co-written 6 books. He has published, lectured, tutored, and consulted internationally for more than 40 years and has been an invited keynote plenary speaker at conferences of ACMSIGCHI, ACMSIGGRAPH, Usability Professionals Association. He was named an AIGA Fellow in 2007 and was elected in 2008 to the CHI Academy. He is the founder of Aaron Marcus and Associates, Incorporated, a pioneering, world-renowned design firm specializing in user interface user experience development applications. A. Michael Knoll. Knoll was one of the first researchers to use a digital computer to create artistic patterns and to formalize the use of random processes in the creation of visual arts. He began creating digital computer art in 1962, making him one of the earliest digital computer artists. In 1965, Knoll along with Frieder Nake and Georg Nies were the first to publicly exhibit their computer art. During April 1965, the Howard Wise Gallery exhibited Knoll's computer art along with random dot patterns by Béla Djulis. Other pioneers: Pierre Barre, copyright Zaire, Jim Blinn, Jack Briesnam, Paul de Casteljau, Ed Catmull, Frank Crowe, James D. Foley, Henry Fuchs, Henri Gouraud, Nadia Magnanet Thalmann, Binaur registered trademark T.B. Mandelbrot, Martin Newell, Frederick Park, David John Pearson, Bui Chuang Fong, Steve Russell, Daniel J. Sandin, Alvy Ray Smith, Bob Sproul, Ivan Sutherland, Daniel Thalmann, Andres Van Dam, John Warnock, Lance Williams. Study of computer graphics. The study of computer graphics is a subfield of computer science which studies methods for digitally synthesizing and manipulating visual content. Although the term often refers to three-dimensional computer graphics, it also encompasses two-dimensional graphics and image processing. As an academic discipline, computer graphics studies the manipulation of visual and geometric information using computational techniques. It focuses on the mathematical and computational foundations of image generation and processing rather than purely aesthetic issues. Computer graphics is often differentiated from the field of visualization, although the two fields have many similarities. Applications. Computer graphics may be used in the following areas. References. Further reading, L. A. Marl and K. Zhang. Computer Graphics for Java Programmers, 2nd edition, John Wiley & Sons, ISBN 978-0-470-03160-5. David Rogers. Procedural Elements for Computer Graphics. McGraw-Hill. James D. Foley, Andres Van Dam, Stephen K. Feiner and John F. Hughes. Computer Graphics, Principles and Practice. Addison Wesley. Donald Tierney and M. Pauline Baker. Computer Graphics. Prentice Hall. Francis S. Hill. Computer Graphics. Prentice Hall. John Lewell. Computer Graphics, A Survey of Current Techniques and Applications. Van Nostrand Reinhold. Jeffrey J. McConnell. Computer Graphics, Theory into Practice. Jones and Bartlett Publishers. R. D. Parslow, R. W. Prowse, Richard Elliott Green. Computer Graphics, Techniques and Applications. Peter Shirley and others. Fundamentals of Computer Graphics. A.K. Peters, Limited. M. Slater, A. Steed, Y. Crisango. Computer Graphics and Virtual Environments, From Realism to Real-Time. Addison Wesley. Wolfgang Haar. Paragraph HL, Interactive Environments with Open Source Software, Springer Wing, New York, ISBN 3-211-79169-8, External links, A Critical History of Computer Graphics and Animation, History of Computer Graphics series of articles, Computer Graphics Research at UC Berkeley, Thomas Dreer, History of Computer Art, Chap. 4.2 Computer Animation.